If you're thinking about buying a 3D printer or you're just getting started, you will come across a lot of terms that don't make any sense at first. Warping, layer height, ASA, and that's exactly why today I'm going to explain you every term you need to know. And even if you're already a little bit more advanced, I bet you will learn something today. Let's start with the most obvious thing, the filament. That's simply the raw material, the thing on the spool. This stuff on the spool that gets fed into the printer and then deposited layer by layer. There is not the one filament, there are many different materials and so on, but we will get into more detail later. Now, hot end and nozzle. The hot end is the heart of every FDM 3D printer. FDM simply means it's a filament 3D printer. There are also SLA 3D printers that work with resin, or there are other 3D printers that work with other things. There's so many different ones, but most people talk about FDM 3D printers. Inside the hot end there is a heater block with a nozzle screwed into it. The filament comes in front the top, gets heated just before the tip and comes out liquid like a hot glue gun. The nozzle has a diameter, the standard is 0.4 millimeter. That's the all-arounder. The smaller the nozzle gets, the better the quality is, but the more time it takes to print something. And the bigger the nozzle is, the less quality you get, but the more speed you have. The extruder is what actually pushes the filament through the printer. A gear trips the filament and pushes it towards the hot end. Without it, nothing works. There are direct and Bowden extruders, but that's a whole separate video. In short, direct extruder means the gear sits in a printer head, and Bowden means it sits somewhere off the side. On the hot end there are also two fans, and they have a complete different job. The hot end fan cools the upper part of the hot end so the filament doesn't melt right here. The part cooling fan blows directly onto the nozzle so the freshly printed material solidifies immediately. Both are important, neither one is optional. The print plate is the plate where your models get built. The build volume, also called the print space, is the usable area of your printer. Now we've talked a lot about the hardware, but what if you actually want to print something? The first thing you need to do is to find your model. There are a lot of different sites online. You can go to Printables or MakerWall. These are the two largest ones. Let's say we want to print a desk organizer. So we go to the search and search for desk organizer. Now we download the model and we get this weird STL file, but our printers can't do anything with this file. Here we need the so-called slicer, where it's the software that tells your printer what to do. You don't fed your 3D printer a 3D model. Instead you load it to the slicer and it creates a file that the 3D printer can work with. Almost every 3D printer has its own slicer, Anycubic slicer, Snapmaker slicer, Creality slicer, Prusa slicer and so on. And there are standard profiles you can use. Now we load our 3D model into the slicer, and on the right we have these so-called profiles, like a speed profile, normal profile and so on. And let's stick with the normal profile, and then you go on the right and there is the text slice now. You click this and you're done. Now you get this file called G-code. This is the file you give your 3D printer. There are still a few settings worth knowing because they come out in a lot of videos and it's very interesting. The most important setting, it's called layer height. That's also the number that shows in your profile, 0.1 quality profile. The printer builds your model from individual layers. So the thinner these layers are, the more detail you will get. But the longer the print takes, because like for this one he needs to do 1, 2, 3, 4, 5, you know. But if you use big lines, maybe it will just do 1, 2. You know what I mean? So the normal rate is 0.2. This is like the number you can use for almost everything. Then there are skirt, brim and rafts. So the skirt will create a few lines around your model. No contact with the part itself, just used to prime the nozzle with material before the actual print starts. Brim, attached directly to the part, increases the adhesion surface on the bed, useful for parts that would otherwise come loose. a raft, a full plastic raft beneath the model for parts with minimal contact area like spears get peeled off afterwards. Now we have the infill, because this will actually save you some money. Infill is the fill inside your part. You don't need to fill it 100%. 20% is often enough for good strength, but saves 70 to 80% of the material. Here you can see a comparison between 20%, 70% and 100%. So just to keep that in mind, if you want to print something really solid, you should use 50 to 70%. But if you're just printing like a Deadpool bust, you can use like 10%. There are also different fill patterns. These three are the most commonly used ones. But at the beginning, honestly, they're absolutely irrelevant. But I just wanted to show you because it looks cool. Retraction is also one of the most important features. When the nozzle travels from A to B without printing, the liquid material keeps oozing out and forms rings. That's called stringing. With retraction, the printer briefly pulls the filament back before changing positions, and that's prevent the string. The good thing is that with new printers and the new slicers, you don't need to worry about that because you have it in the standard settings. But stringing can still happen. And one of those reasons, and I would say the most important one, is wet filament. So your filament can absorb the moisture from the air. There are many different things you can do to prevent it. One thing is to try to store your filament in low humid areas. I, for example, store all my filament in these IKEA boxes and I just put some silica gel inside of them. There is hope because not every filament will absorb so much moisture from the air. If you're printing with PLA, you don't really need to worry about that. Which brings me to the different materials. As I mentioned earlier, there are different variations: PLA, PTG, ABS, SA, TPU. There are obviously a lot more, but these are the most important ones for the hobby. I will keep it brief today and I made a whole video about this topic. Let's start with PLA. This is the standard material. It's used for figures and simple holders. It doesn't hold up particularly well and it only heat resistance up to 60 degrees, meaning it's not suitable for parts in a car. You mainly use PLA for decorative prints and small everyday helpers. PTG is similar to PLA, except you get significantly better load bearing capacity and heat resistance. I use PTG whenever I need holders that have to keep more stress. For example, if you want to hang up an extension cable. TPU is flexible, so you can print like phone cases or like your own shoes. This is really cool, but not so easy to print. ABS you already known from everyday life. Almost everything around us is made of ABS. Like the housing of your TV remote, it's a bit trickier to print and requires a so-called enclosed build volume, which you have when your printer has a door like this, simplified. The material is also even more robust than PTG. ASA is like ABS, but with added UV resistance. So if you want to print something for your garden, for example, you could use ASA. Supports are also super important, because there are a lot of models that have floating parts and you can't print it mid-air. For example, if you have a figure that looks like this here, you have the arm here, and you see a printer can't do this because the material will go down. So you print a structure that helps it to be on top. This is also a whole topic, but to simplify it, you can just click automatic supports and hope for the best. I hope you learned something today. And if you want to know more about filaments, click this video. And if you want to see a printer review, click this video. Thank you for watching.